Okay, next up, Nathalie Heidi Meyer, and presenting her title of her talk is Premotor-hippocampal connectivity at encoding links the sense of self in the past and present.
Hello everyone, it's a great pleasure for me to be here today and to present part of the work I did during my PhD thesis at the Swiss Federal Institute of Technology. So today I will talk about how bodily self-consciousness impacts long-term memory. So to give you an idea of the big picture, I can, okay. So to give you an idea of the big picture, in our everyday life, we are constantly encoding new events. And the one thing we have in common between the encoding of all those events is that we always have a body. And that's this body which is receiving all the different stimuli that we encode actually during those events. So it can be external stimuli, such as auditory, visual, but also internal stimuli, such as your heart beating, for example. And so this multisensory and sensory motor integration of this bodily signal is also thought to give rise to a subjective feeling of being oneself in one's own body, which we call bodily self-consciousness. So to simplify, we can decompose this bodily self-consciousness into four main sub-experiences, which are the experience of the world at the first-person perspective, to have the feeling that the body you have is your own and that you're in control of it, so it's what we call body ownership and sense of agency, and to have the feeling that yourself is located within your own body. So part of my thesis was to try to understand how this bodily self-consciousness that we have during each experience of an event actually impact our way and our ability to re-experience this event. And our ability to re-experience an event is called autonoetic consciousness. So luckily, I did not start from scratch, and actually there are more and more behavioral experiments, mainly, that show that when you reduce bodily self-consciousness during the encoding of an event, you also obtain a reduction of long-term memory. So there are different measures of long-term memory across studies, so it can be more about the strength of the re-experience you have, but it can also be measured with recognition performance, and in that case you would have a lower performance when you encode something with reduced bodily self-consciousness. So although we have now more and more behavioral evidence showing that there is an association between those two high cognitive functions, we still don't really know how it works and where it takes place in the brain. So far, the studies converge into showing that the hippocampus seems to be modulated by a manipulation of bodily self-consciousness. So different studies have reported reduction of hippocampal activity, hippocampal range statement, and also hippocampal functional connectivity with the parahippocampus when you encode events that have a reduced bodily self-consciousness. And recently, our group has reported a positive relationship between the range statement of the left hippocampus and the range statement of the left dorsal premotor cortex during a recognition task. So the left dorsal premotor cortex is actually already known to be involved in bodily self-consciousness and mainly sense of agency. And we found that this positive relationship was actually only held for scenes that were encoded under preserved bodily self-consciousness. So what I'm going to present today is a simple follow-up of this observation, and we just wanted to understand whether the link between the left hippocampus and left dorsal premotor cortex could also explain other type of memory, such as autonoetic consciousness, or whether it was really specific to a recognition task. So for that, we had a cool setup where we immersed participants in virtual reality while they were in the scanner, and we asked them to move their right hand in a vertical movement. And then they were immersed in 3 different scenes, and each scene was corresponding to a different level of bodily self-consciousness. So in the first scene, the participant would observe an avatar at the first-person perspective, and the avatar would move in synchrony with their own movement. So we kept the sensory motor integration, and we were expecting to have a preserved bodily self-consciousness. But then in the second scene, we add a delay between the participant's movement and the avatar movement. So we would disrupt this sensory motor integration and the related bodily self-consciousness. And in the first scene, on top of the delay, we also shifted the perspective to introduce like a stronger manipulation of bodily self-consciousness. And then we ask the participants to rate their level of sense of agency and body ownership in another scene for each condition so that we have a measure of their bodily self-consciousness. And 1 week later, outside of the scanner, we ask the participants to just fill out an autonoetic consciousness questionnaire, which is usually used for a real-life event and for autobiographical event. But here we ask them to fill the questionnaire for each of the scenes they encoded. So it's a questionnaire with 28 items, and you have questions such as, my memory for this event involved touch, or I remember how I felt at the time when the event took place, etc. So those are the behavioral results. So first we check that our manipulation work and that we actually have a reduction of bodily self-consciousness in the two conditions where we wanted to manipulate it. And we found that indeed there is a reduction of sense of agency and ownership for those two conditions, so we're good. But of course, our main interest was to understand how this bodily self-consciousness was related to autonoetic consciousness, so the strengths of our re-experience 1 week later. And we found that actually, the higher your bodily self-consciousness during the encoding of an event, the stronger was your re-experience 1 week later. But this was only held again for event encoded under preserved bodily self-consciousness. So this was behaviorally, but of course, our main interest was to understand within the brain whether we can find a trace of that. So we looked at the functional connectivity between the left hippocampus and the left dorsal premotor cortex, and we found that actually there is a difference of functional connectivity strengths across conditions. So participants had a stronger functional connectivity when they encoded scene under preserved bodily self-consciousness. And we also checked on the reverse hemisphere, the hemisphere ipsilateral to the movement side, to make sure that this was more specific to our manipulation. And indeed, on the other hemisphere, we did not find such difference. So the last step was to try to put everything together. So now we know that the functional connectivity strength is kind of a neural proxy for our different conditions. So we tried to compute a linear mixed model to explain autonoetic consciousness by the interaction of bodily self-consciousness and the functional connectivity. So when we tried to do that for the whole autonoetic consciousness score, we didn't find anything, unfortunately. But then we did a factor analysis to divide our questionnaire into 3 different subfactors and then simplify a little bit what we wanted to explain. And we found that our factor number 2, which give high weight for item about tactile sensation and what the participants were thinking and feeling during the encoding. So this part of the questionnaire could be explained by the interaction between bodily self-consciousness and the functional connectivity. So in short, if you had a strong functional connectivity, you have a steeper relationship between your sense of self in the present, and hence the title, so your bodily self-consciousness, and part of the re-experience of the event, so your sense of self in the past. And this interaction was, again, only specific for the left hemisphere, and we didn't find it for the right hemisphere. So that's it. So to sum up, this is only, I think, the beginning of the story. So we try to link 2 high-level cognitive functions, which are bodily self-consciousness and long-term memory. And with this study, we found that the functional connectivity of the left hippocampus, which is known to be memory-related, and the left dorsal premotor cortex, known to be bodily self-consciousness related, can actually grasp part of this association. So yeah, that's it. I thank you all for your attention. And of course, this is a teamwork, so I also want to thank everyone who participated to the work. And I also have a poster this afternoon, number 835.
Thank you. Any questions from the audience? Yeah.
Thank you. That was a really great talk. I was interested in the fact that the last results that you presented with the connectivity predicting autonoetic consciousness, it sounded like you said that the aspect of your questionnaire was around what people were actually thinking at the time of encoding. And so I wonder if you have any thoughts about why that's related to this kind of hippocampal premotor connectivity.
Yes, so that's a very good question. Thanks a lot. So actually we were expecting to find such kind of relationship mainly for more visual aspects because our task is mainly visual. So it was a bit surprising that it was mainly about what they were thinking. So maybe, so honestly, I don't know, like we still need to think about it a bit more. Maybe the visual component, like the problem is that this questionnaire is built for autobiographical memory events, and now we use it for virtual events. So I think there's still a lot of fine-tuning to do to improve the question and make them more suitable for our task. So yeah, I'm sorry, I don't have better explanation.
And I'm just wondering, can you think of a way how we could increase the sense of our body ownership to then increase our memory?
Yeah, I received this question a few times. It would be cool. So far, I don't think for healthy people we can increase sense of agency because I think our baseline is that we have a successful sensory motor integration. But I think for non-healthy people who have a problem or an issue with this integration, maybe then we can try to improve it and then they can improve their memory. But yeah.
Yeah, I'm wondering maybe something like an ice bath or something, you know.
Yeah, I need to think about it more, but it would be cool.
Thank you.
Thank you.